So we've seen molar solubility in water. We're going to start with the molar solubility in water and then see what the common ion effect is. So again, let's start from scratch. Ag2CrO4, silver chromate. And we're going to just see what its molar solubility is in water. So 2Ag plus aqueous plus CrO4 2 minus. So we start at 0. We're going to add 2x, x, and x, stoichiometry. Now, let's set up our KSP equation. Equals the concentration of our Ag plus. Remember, the 2 does not go inside the brackets, it goes on the outside. It's as a square. And then the concentration of our CrO4 2 minus. Now let's put our x's in there. So 2x squared times x, and we get 1.1, oops, a little too high, 1.1 times 10 to the negative 12 divided by 4. I've just gone ahead and squared the 2 and I'm dividing by it. And x squared times x is going to give us a cubed. So we're going to take the cubed root of this to find out what x is. And punch it in our calculators. We get x is 6.5 times 10 to the negative 5. Now for fun, let's remind ourselves what that is. We'll go to a different color. So that means that our concentration of chromate is 6.5 times 10 to the negative 5. And if we want the concentration, so let's go ahead and make a note of that. This is chromate ion concentration. And the concentration of our silver, Ag plus, is going to be 2 times x. So that will be 1.3 times 10 to the negative 4. So don't forget we have this 2x. So this is measured in lab, probably using some sort of titration to get mole-to-mole ratio and work our way. So you would determine what this is in lab, but to find out what it is with our stoichiometry, that's when we need to involve our x, and we get the 1.3 times 10 to the negative 4. So again, when we look at this x here, that also means our molar solubility. We have, if we assume that it all is soluble, well, plus x, that means that this is also x. So our molar solubility of this silver chromate is x. It is this 6.5 times 10 to the negative 5. So now let's put it in something and see what happens. Go back to black. Whoops. Now, how are we going to do this? Well, let's start off by looking at what the potassium chromate is doing. We have potassium chromate, CrO4, in solution is going to give us 2 potassium ions plus 1 chromate ion. Now we're told that it's 0.1 molar, so then we're going to assume that both our potassium ions and our chromium ions are also 0.1 molar. Well, the chromate ion is 0.1 molar. We'd have to do a calculation on the potassium to figure out what that is. So we have 0.1 of this to start with. So let's rewrite our original equation. Of Ag2CrO4 in solution with 2Ag plus CrO4 2 minus. This time, though, if we're mixing the two solutions, we're not starting with 0, we're starting with that 0.1 molar of the chromate ion, who's our common ion. Silver, we're still starting with 0, plus x, plus x. So the one thing I want to point out here is this is 0.1 molar. Let's do this in red. 0.1 molar. And if we go back, we see that we have x here is like 6.5 times 10 to the negative 5. So this is much, much greater than 6.5 times 10 to the negative 5. So this change in x here, we'll go ahead and ignore. And I'm going to write it that way so you don't make a mistake and carry it through and accidentally end up with an x cubed at the end, because that'll throw your answer off. So we still have the same KSP, our 1.1 times 10 to the negative 12. And that is now going to equal, oops, plus 2x. That is going to equal our 2x squared times the 0.1. Because remember, this number is much, much bigger than what we could get here. So it is just the 0.1. And so we simplify that down, it becomes 4x squared times the 0.1, so 0.4. And we get the square root of 1.1 times 10 to the negative 12 divided by 0.4. And that gives us 1.66 times 10 to the negative 6 molar. So this is the amount that will dissociate, moles per liter, of our silver chromate in a potassium chromate solution. Well, how does that compare? Well, we can see that it's actually smaller. Where'd it go? Here we go, to this number, right? So when we have the common ions in there, we are diminishing the amount of solubility because we're starting with something to begin with.